Hey chaps, and welcome back. This is just a continuation of the previous episode, so I'm going to spare you the ramblings at the start of the video and just get straight on into the content. To serve as a quick reminder, however, we are at the stage now where we're about to add the tile properties to the class to identify which tile set and tile frame it uses. So to get us started, we need to add some more information to the tile class. This is so we know what tile set to pull from and what tile frame we need to pull from that tile set when we draw it. So in the engine project, we're going to head to tile maps, tile class, and then in here we're going to add a couple of int properties to represent that information. We're going to have a public int tile set index get set, and then a public int tile index get set. Okay, so the tile set index is the index of the tile set in the list, and then tile index is the index of the frame in the list of frames in that tile set. So now we've added that information, we need to start thinking about adding some functionality to the tile set previewer, such that when we click on it, it will then select a tile for us. Click event on the tile set picture box. This is of course so we can detect when a click has been made on the picture box and then decide what tile has been selected from that. So to do that, we're going to handle it in code, much like the paint event. So I'm going to type tile set picture box click plus equals and then use Visual Studio's handy option for inserting an event handler. So I'm going to press tab. In here, the first thing I'm going to do is check to see if there is a tile set, and if not, I'm going to return out. Much like the paint event, there's no point going any further if there's no tile set to even interact with. Secondly, we need to pull out the mouse event args. Now, in actual fact, these event args here, E, are the mouse event args. We just need to cast them ourselves. Mouse event args equals mouse event args, if I can spell them correctly, E. In case you're wondering how I could work that out myself, if I put a breakpoint on this line, hit start, select a tile set, and then click within the tile set to invoke the click handler, you'll see down the bottom here the variable E on the right, in actual fact, is a mouse event args object, although it does extend event args, hence why this is possible. Okay, so with the event args, we now need to turn the mouse event args into a position or a point, so we can then check to see if any of the frames contain it. Now, similar to the rectangle situation, there are multiple points. There is a system point and a MonoGame point. So what I'm going to do is add an alias at the top of the file to differentiate the two, much like we did for the rectangles. However, I only need the MonoGame point this time, so I'm only going to define an alias for that one. So I'm just by MonoGame point equals Microsoft.xna.framework.point. Okay, back down in our event handler, I'm going to define one of these. So MonoGame point mouse point equals new, and then I'm going to pass in the mouse args.x, mouse args.y. So now we have the position of the mouse within that tile set box. What we need to do next is go through each and every frame to check to see if the frame contains this point, and that is why we've made it a point, as it makes this process a lot easier. So I'm going to copy some code from the paint event, more specifically when we get the frames, and loop through them, like so. There we go. Okay, and then the only thing I need to do in here to check to see if the frame contains the mouse point is pull that frame out of the list, i.contains mouse point. At this stage, I now know this frame has been selected because we know we only need this code when we've clicked, and the only time I should land in here is when we've clicked and it's fallen within this frame rectangle. So we know we've selected this tile. So what we're going to do is create an int to store this index so we know at all times what tile is selected. So at the top of the file, I'm going to create a new private int selected frame index. I'm going to default that to -1 because 0 is of course a valid index in an array or a list. So in here, when I've selected a valid frame, I'm going to set the selected frame index to I, so it's the current index of the frame that I'm on. And from there, I know which frame has been selected. Okay, so what I need to do now is differentiate a selected frame from the others. So what I'm going to do in my paint call is actually say when I have a selected frame and this is it, I'm going to change the color of it. So in here, before I draw the rectangle, if selected frame index equals I, then what I'm going to do is just draw it in a different color. So here, else. So if it's selected, I'm going to draw it in red. Okay? So we're looping through the rectangles as we're drawing them. We looped through them here when we clicked on them. We've set the selected frame index to the index of the rectangle we are within and clicked on. And then again, when we're drawing it, we'll check and see, well, is the current frame I'm looking at that I'm drawing the selected frame index? Okay, so if I give that a quick start, drop down the tile set, select one, make a click, you'll see nothing's actually happening. Okay, well, what's going on there? Can we work that out? What I'm going to do is add a breakpoint inside here where we make that selection to check to make sure we're actually hitting the right code. So I've got a breakpoint in here where we're setting the selected frame index. I'm going to click on the first tile and we have hit the code correctly. Is it the correct index? Well, I is 0, so yes, that is the first tile. I'm now going to select the second tile and I should be 1, which it is. So that's all working. The selected frame index is being set correctly. If I step over, yes, it is 1, that is all working. But why is it not drawing correctly? Well, that's because what you're seeing here is only drawn the once, and we need to tell it to redraw once we've made this frame selection. So to do that is actually simple as well. So to do that, I just need to type invalidate here, but that won't work because it's not on the tileset picture box. So what I'll do here is tileset picture box dot invalidate, and that will cause the tileset picture box to redraw itself. Okay. So in here now, I'm going to start up again, select tile set, and select a tile, and you'll see the tile that I'm selecting is in fact being drawn in red as I'm clicking. Okay. The next thing we need to do is create and raise our own events. Up to now, we've only handled system events such as click and paint, but really it would be useful to raise an event here when we've made a tile selection so we can delegate the responsibility of what happens to other components. To do that, we need to define what is called a delegate, which is essentially what defines the parameters that are passed to the event. So in here, when we handle the click event, there will be a delegate defining sender and event args. So to do that, we'll go to the top of the file, type public delegate void, and then in here, it's just going to be called on tile select handler. And then we define what parameters are passed to it. In our case, I just want to pass the tile set, and then the selected frame index. Okay, the second thing we need to do is define the event itself. To do that, we type public event on tile select handler, and then we give the event a name. This will be tile select. Alright, so down here where we're handling the code for invalidating the form and selecting the frame index, we can then raise an event. To do that, we'll just type tile select, and then what we can do is a quick null check, but I'll show you that in a moment. Invoke, and then we pass in the tile set and selected frame index. Okay, of course, if no one subscribed to that event, this will fall over with a null pointer exception. What you can do is put a null check around it, or simply put a question mark at the front here, and that will check if it's null before invoking it. Okay, so now we have an event that is fired from the tileset previewer when a tile frame has been selected. So it's up to us to now start handling that elsewhere. For now, I'm going to close down the tileset previewer and move on. Our next piece of work is going to be back in the form. So if I go back to Form 1 CS, right click and view designer, give this a quick build to make sure everything's up to date and valid. Now in here, if I select the tileset previewer that we created before, click on the lightning bolt in the bottom right here, there should be an event in here that we can now handle that we've created ourselves. So here it is, tile select. So that is the event we just created back in the tileset previewer. We can now from here add an event handler in the form. So if I double click on this to create the event handler, here we are back in the form with our event handler, and then you can see defined by the delegate, there is our tile set and frame index. So it's up to us now to create a tile which acts as the brush, or create some functionality which acts as the brush, to then perform the painting functionality. The next thing we're going to do is create a tile which will act as our very basic brush. So I'm going to create a tile instance, we'll call this brush tile, equals new tile. So I'm going to set the properties in here, our newly created ones. So this is going to be our tile set index. Now you'll notice here straight away we don't have a tile set index, and the previewer has absolutely no knowledge of that. It's up to us to piece this together based on its position in the bootstrap. So that's really easy for us to do. So I'll just pull this from the MonoGame editor 1. That is our MonoGame editor control, which owns the bootstrap. Bootstrap, tile set, index of tile set. As we know, that tile set has come directly from the Bootstrap list of tile sets, so that will just give us the index of that tile set in the list. Of course, the tile index is just the frame index, and there you have it. So there's our tile index. Oh, sorry, there's our new tile for the brush. Okay, so we have our brush tile. We aren't really doing anything with it. What we need to now do is pass that along to the editor so it can then do some magic with the map. So what we're going to do is actually open up our MonoGame editor, right click and view code. In here we're going to actually have a property which represents the brush tile. So here I'm going to have a public tile, brush tile, get set. Okay. Back in our form, I'm just going to set that to this brush tile. So MonoGame editor 1 dot brush tile equals brush tile. So there's our brush tile. Everything the form needs to do is now done. Everything the previewer needs to do is now done. So let's close these down for now. The next thing we're going to introduce is the concept of immediate tiles to the tile map. The point of an immediate tile is it will be drawn once and then be completely forgotten about thereon. Now this is useful for us in the context of a brush because as we add this immediate tile, as you move the mouse around, it will look like it is just showing a hovered version of your brush instead of leaving a trail behind it. So what we're going to do is we're going to do that right now. If we go to the map class, and here we're going to create a private list, which we may need to add the using statement for. And then we're going to use a construct we've not yet used, and that is a tuple, which we may also need to add the using statement for. So a tuple is actually quite simple. It's just a construct which houses several different types. You can specify any you want up to, I think it's about 7 or 8. So in our case, I want to store essentially an X, a Y, and a tile. So int tile. Okay? Now, if you imagine this is just a list of positions and then a tile, as you're going through it in each frame, you draw it once, forget about it, clear the list down. That's essentially how it's going to work. So I'm going to call this immediate tiles equals new list of immediate tiles. Right. Okay, so with that said, I'm now going to add a method to add to that list. Public void add immediate tile, int X, int Y, and then tile. And then simply add that to the list as a tuple. So immediate tiles dot add new tuple int tile, and then the constructor for this, it just basically accepts an instance or a copy of each of the types you've specified. So X, Y, tile. Okay, so there we have our list, which you're going to add to each time in the editor. So if I do that now, if I go back to the MonoGame editor, in here we've set a brush tile, and you'll see down here we pull out the tile position to be able to set the background color based on a click. Now the problem when we do this, we pull out the whole tile, which is a lot less than we really need because we need the exact position of the tile that we're hovering over. So to do that, we need to change how this get tile position works to be a little bit more descriptive about what it's finding. If we go back to the map class, what we're going to do is change this method to return something else other than a tile, which will be something more detailed. We're going to create a class at the bottom of map, public class map, tile position detail. This is going to return, much like it does already, a tile, but additionally it's going to return a point which represents the coordinates. Okay, so back at our get tile position method, this is now going to return a tile position detail, and we need to create an instance of that to then return. Okay, so that now needs to set the detail.coordinates to the X and the Y. Down here, this needs to return the detail at all times, but then additionally it needs to set the tile to tiles X and Y, and then return detail. Okay, so what this now means is we can have more descriptive behavior around getting a tile at position, such as where exactly it is in the world, the X and Y coordinates of it, and we could probably be more descriptive in future about telling you if it's valid or not, depending on if it's out of bounds. So if we go back to the editor now, we'll have an error in here because this is expecting this to return a tile alone, which it currently does not. But we're going to change this around anyway because we need this information at all times now, not just when you left click. So we're going to move this out of here, up to the top, underneath this mouse get state. Okay, so instead of this now returning the tile itself, it now returns a position detail, so we need to get that instead. So map.tile position detail, tile position detail equals my map.getTile position, passing in the world position as it always did do. The tile now is going to be basically tile position detail dot tile, and that'll either be null or it won't, so this will still work. But then additionally, we can now use this position detail to set the immediate tile. So down here, I'm going to check if the brush tile is not null. I'm going to get my map, add immediate tile, tile position detail, coordinates.x, tile position detail, coordinates.y, and then pass in my brush tile. So we have our concept of immediate tiles, and they should now be drawing in the correct place. The only problem, however, is that we're not drawing the tiles textures, but still the background colors, so we need to change that next. Over to our map class, we have our draw method here, and he loops through the tiles, drawing each tile by filling in a rectangle based on their tile background color. So what we need to do is create a draw method on the tile to start encapsulating this, especially now we're going to be using it in multiple places. Going to the tile class, we're going to add a method in here, public void draw, and he's going to take a bunch of arguments which we'll now work out. Back to the map class, what do we need? We need the sprite batch, the tile position, the tile width, and tile height. Okay, so back to the tile class, so we need a sprite batch, a vector2 tile position, an int tile width, and an int tile height. And using that, we should now be able to port over this code here. So take the sprite batch filling the rectangle, both of them, and place them into this draw method. Rename the variables where appropriately, and we don't need to refer to it as tile background color because within the tile. Okay, so now we should be able to call tile.draw, passing in the sprite batch, tile position, tile width, and tile height. If I refer to the sprite batch correctly. Okay, I've omitted the tile width and tile height from the tile itself because it just makes more sense that the owner that draws it knows more around the size than it does. It just needs to know the data around that specific tile. Okay, so with that said, let's give that a start and we should have the next same behavior, which we do. I should still be able to click, which I can, and navigate around, etc. So that's all good. So the next thing we need to do is start thinking about drawing them based on their textures. To do that, we first need a little bit more information, and that is the tile sets themselves. So we need to start accepting that as another argument into the draw method. So at the end here, I'm going to accept a list of tile set and call this tile sets. Additionally, I'm going to pass that down to the tile. So I'll pass this in as tile sets. Go to the draw method of the tile, and now add it onto the method here. Might need to add a using statement for the list, control period, using system collections generic, and there you go. Let's give this a quick build. We'll have a couple of errors. So the first one will be in the editor, the second one in the game itself. So if we go to the editor, the last argument on here is relatively simple. We just refer to the bootstrap.tilesets. Then the game itself does not currently have a bootstrap set up, so we need to actually just give this a new list of tile sets. Add the using statement to the list. Okay, so when we come to moving forward after we've got the tile map saving, we'll come back to the game and bootstrap it up. Closing that down now, heading back to the tile class. In here we now need to add some code to make sure it draws based on the texture, if there is one. And to do that, we first need to consider the fact that the tileset index and tile index both have a valid entry of 0, so we need to default them to -1. Much like we did with the selected frame index on the tileset previewer. In here, in the draw method, we just need to check to make sure that these are both not -1, therefore are valid indexes or indices. If tileset index is different to -1 and tile index is different to -1, and then we just need to draw the texture. So first of all, let's pull the tileset out of the list. Tilesets, tileset index, and then we need to draw the texture based on the frame. So, okay, so how we do this is we call the sprite batch draw tileset dot texture, so that's the texture, the destination rectangle, so that's a little bit different. So to do this and specify a source rectangle is not necessary, so all we need to do is pass in tile position, and then the source rectangle just becomes the frame itself. Tileset dot frames tile index. capital T. The color just becomes white. Okay. Now, this is when there's a tile set texture present. So let's just give this a quick run now and see how that looks. Press start. Select a tile set. Select a tile. Hover over here and you'll see nothing happens. And the reason for that is because we're not yet drawing our immediate tiles. If we head over to our map class, to our draw method, at the bottom of here we're going to add one more loop to loop through our immediate tiles. So I equals 0, I under immediate tiles, dot count, I plus plus. Okay, so then we're going to pull our tuple out of the immediate tile list. Now I'm going to use something called destructuring here to actually pull them out and name them at the same time. So if I type var xy tile, remember that's what was in the tuple list, xy tile, equals to immediate tiles I. Oh, what have we got there? Immediate, I can't spell it right. Okay, so now over int x, int y, and tile called tile. So with that said, we can now get the tile and draw using the sprite batch, the tile position, which we now need to calculate again in this loop down here. And then this is just x times tile width, y times tile height, which is pulling straight out of this tuple. And then we're going to pass that in here as well. So tile position, tile width, tile height, and tile sets. Okay, so if I give that a quick run now, select a tile set, select a tile, hover over the tile map, you'll see this is happening. So this is because of two reasons. The trail is because we're not clearing down the immediate tile list like I said we should do. And the white is because we're drawing a white square over the top of the tile set image. So let's close this down. Down here, what we're going to do is clear down that immediate tile list after the sprite batch ends. So immediate tiles, clear. Give that a run again, and that should clear one of our problems. So it's tile set, select a tile, hover around. So there you go. The next problem is, of course, the fact it's drawing a white square over the top. So if we head to our tile class in here, you'll see the first thing we do is draw a big whopping white square. And then we draw another square in the background color. The white square is in actual fact just to provide the border that you see. So really it's not entirely necessary, especially because we always have a background color now. So what we're going to do in here is just remove these two calls for now so you can see it working. Hit start. Select a tile, set, select a tile, hover over here, and you can see it working just fine over here. Okay, so how are we going around fixing this problem? Well, all we need to do is move the first drawing of a rectangle, the white one, to the top of the draw call of the tile, and then only draw the coloured background tile if there is no valid tile to be drawn. So if we move that one into there, remove the commented out code, give that a quick run, and everything should be fine. If I select a tile set followed by a tile, and that works absolutely fine. Okay, you will notice, however, if I move outside of the tile map, this is not working. It will let me hover around anywhere in the world, regardless of whether it's a valid tile or not. So if I head back to the map class, in here we need to expand this somewhat just to encapsulate whether it's a valid position or not. So to our tile position detail class, I'm going to add a public bool is valid position. A simple yes or no question. So up here, what I'm going to do is paste this into here, or rather just create a new block here under the if boundary check. Detail is valid position equals false, and then underneath detail is valid position equals true. So they're the only valid scenarios they could be. So now over in the map class, or actually it'll be the editor class, I lied to you. In here, when we add the immediate tile, we just need to check to make sure that it's a valid position first. So if brush tile is different to null and tile position detail, it was called, is valid position, only then add it as an immediate tile. Give that a quick run again. Set a tile set followed by a tile, and you'll see I can hover it around over the tile map fine, but I can no longer move it outside of the tile map. The last thing we need to tackle here is actually painting of the tile onto the map, and that itself again is really, really simple. In here, where we check the button is up, so this checks to see if the left button is being pressed down and lifted up, so clicked, we changed the colour of the background previously. Now I'm going to change this to only check if the button is down. This will allow us to hold it down and paint. And in here, when it checks to see if the tile is not null, I'm also going to check to make sure the brush tile is not null. The only thing we then need to do after that is just copy the details over to the tile, and that is it. Tile.tilesetIndex is equal to brush tile.tilesetIndex, and you can see where I'm going with this. Tile.tileIndex is equal to brush tile.tileIndex. Okay, let's give that a quick run again. Select a tile set followed by a tile, and there you can see it's hovering over fine. But additionally, now if I hold down the left mouse button, I can paint it into the world, and that's working absolutely fine. I can select another tile and paint that one as well. So there we have it, the tiles are painting and not a problem. So we have the functionality now that we can select a tile to paint onto the tile map, and this just opens up a whole world of doors for us. With that said, we've reached a massive milestone today, guys. We've been working towards this for quite a while, so I hope you're all reaping the benefits of the work you put in so far, and I hope you've enjoyed following it up to this point. I look forward to working on the next part of the series, and until then, I'll speak to you soon.